Welcome to this lesson on projectile calculations. Today we will explore two fundamental quantities in projectile motion: horizontal range and maximum height. Range tells us how far a projectile travels horizontally, while maximum height tells us the peak vertical distance it reaches. Understanding these concepts is essential for analyzing any projectile motion problem. This is part of our motion series where we break down the physics of moving objects. Before we dive into the formulas, let's understand the basic setup of projectile motion. When we launch a projectile, we need to know two key things: the initial velocity, represented by the letter U or V subscript 0, and the launch angle theta, which is the angle above the horizontal. The initial velocity can be broken down into two components. The horizontal component is U subscript x equals U cosine theta, which controls how fast the projectile moves sideways. The vertical component is U subscript y equals U sine theta, which controls how high the projectile goes. These two components work independently and together determine the complete motion of the projectile. Now let's look at the formula for horizontal range. The range r is given by the equation r equals u squared sine 2 theta divided by g. Let's break down what each symbol means. R represents the horizontal range, which is the total horizontal distance the projectile travels from launch to landing. U is the initial velocity or launch speed of the projectile. Theta is the launch angle measured from the horizontal direction. And g is the acceleration due to gravity, which is approximately 9.8 meters per second squared on Earth. Notice the formula uses sine of 2 theta, which is a key factor in determining how far the projectile will go. Here's an interesting question. At what angle should we launch a projectile to get the maximum possible range? The answer is 45 degrees. But why is this the optimal angle? It comes down to the sine 2 theta term in the range formula. The sine function reaches its maximum value of 1 when the angle is 90 degrees. So if sine 2 theta equals 1, then 2 theta must equal 90 degrees, which means theta equals 45 degrees. At this optimal angle, the range formula simplifies to r maximum equals u squared divided by g. This means 45 degrees gives the perfect balance between horizontal and vertical motion to achieve maximum distance. Next, let's examine the formula for maximum height. The maximum height h is given by the equation h equals u squared sine squared theta divided by 2g. Again, let's understand each variable. H represents the maximum height, which is the highest vertical point the projectile reaches during its flight. U is the initial velocity or launch speed. Theta is the launch angle from the horizontal, and g is the acceleration due to gravity. Notice this formula uses sine squared theta instead of sine 2 theta. This difference is crucial because height depends only on the vertical component of velocity, while range depends on both horizontal and vertical components working together. What if we want to achieve the maximum possible height? To maximize height, we need to launch the projectile straight up at 90 degrees. This makes sense intuitively. All the initial energy goes into fighting gravity and gaining altitude, with no horizontal motion. Mathematically, sine squared theta reaches its maximum value of 1 when theta equals 90 degrees. At this angle, the height formula simplifies to h maximum equals u squared divided by 2g. Notice that even though maximum height and maximum range both depend on the launch angle, they occur at different angles. 90 degrees for maximum height versus 45 degrees for maximum range. You cannot maximize both at the same time. Let's work through a practical example to calculate the range of a projectile. Suppose we launch a projectile with an initial velocity of 30 meters per second at an angle of 45 degrees, and gravity is 10 meters per second squared. We start with the range formula. R equals u squared sine 2 theta divided by g. Substituting our values, we get r equals 30 squared times sine of 90 degrees divided by 10. Remember, 2 times 45 degrees equals 90 degrees. 30 squared gives us 900, and sine of 90 degrees equals 1. So we have 900 times 1 divided by 10. This simplifies to 90 meters. Therefore, the projectile will travel a horizontal distance of 90 meters before landing. Now let's calculate the maximum height of a projectile. Suppose we launch a projectile with an initial velocity of 40 meters per second at an angle of 60 degrees, with gravity equal to 10 meters per second squared. We use the maximum height formula. H equals u squared sine squared theta divided by 2g. Substituting our values, we get h equals 40 squared times sine squared of 60 degrees divided by 20. 40 squared equals 1600, and sine of 60 degrees is approximately 0.866, so sine squared of 60 degrees is 0.75. Therefore, we calculate 1600 times 0.75 divided by 20. This gives us 1200 divided by 20, which equals 60 meters. So the projectile reaches a maximum height of 60 meters above its launch point.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.